Right now, as you sit watching this, you probably feel perfectly still. But if you are anywhere near the equator, you are actually hurtling eastward at just over 1,000 miles per hour. The reason you don't feel this intense speed is the exact same reason you can casually drink coffee in a car driving down the interstate. As long as velocity is constant, your body has no physical way to perceive the motion. You only feel the speed when that state of constant velocity is interrupted. If that car hits a brick wall, the vehicle stops, but inertia dictates that everything inside keeps moving forward at highway speeds. Now, apply that basic law of physics to the entire planet. What happens if the Earth's 1,000-mile-per-hour spin simply stops? It wouldn't be a gentle pause. An instantaneous halt means an immediate, violent transfer of all that rotational momentum to every unanchored object, building, and drop of water on the surface. At the exact moment the Earth's crust breaks to zero, the atmosphere does not. Everything resting on the surface continues moving east at the exact speed the planet was rotating. The atmosphere maintains its momentum, instantly generating supersonic winds that exceed 1,000 miles per hour at the equator. To put that scale of kinetic energy in perspective, these gusts are nearly 5 times more powerful than the strongest hurricanes ever recorded. And the atmosphere isn't the only fluid maintaining its eastward trajectory. The world's oceans hold on to their momentum as well, sending colossal volumes of water surging toward the eastern coastlines of every continent. This creates mega tsunamis miles high. These walls of water would scrape the ocean floor and easily vault over coastal mountain ranges, flooding the lowlands beyond. Within minutes, the kinetic energy of the planet's previous rotation effectively erases surface civilization. But the destruction goes deeper than the surface. Because Earth spins, centrifugal force pushes material outward, making our planet an oblate spheroid that flattens at the poles and bulges at the equator. This diagram illustrates how that oblate shape forms, showing the polar radius labeled RP and the longer equatorial radius labeled RE. Without spin, you lose the centrifugal force maintaining that bulge. The crust immediately buckles and compresses, settling into a perfect sphere. The sheer physical stress of reshaping the entire globe would crack tectonic plates, triggering massive, simultaneous earthquakes and volcanic eruptions around the world. Gravity would then redistribute the oceans. Earth's spin currently holds a bulge of water 8 kilometers high around the equator. Without that spin, gravity pulls all that water straight toward the poles. This topographic map shows where that water would go. The northern lowlands of Canada, Siberia, and Europe would drown entirely under a new northern circumpolar ocean, while retreating equatorial waters reveal a single massive continent wrapping around the globe. This planetary breaking would shatter the crust and relocate the oceans, physically redrawing the map of the world. For anything that survives the initial shockwave and tectonic realignment, the environment becomes completely hostile. With no spin, a single day lasts an entire year, locking half the globe in 6 months of scorching continuous sunlight, while the other half freezes in 6 months of total darkness. Below ground, the stationary planet also stops the churning flow of liquid iron in the outer core. This motion is what generates Earth's magnetic field. When that magnetic shield collapses, the surface is stripped of its protection, leaving the landscape entirely exposed to deadly cosmic and solar radiation. Fortunately, a sudden stop is physically impossible. This chart tracks the precise retardation of Earth's rotation clock, showing that while our spin is slowing down due to friction from the tides, the rate of decay is measured in tiny fractions of a millisecond per year. We are safely anchored in a delicate, temporary balance. The life we know is only possible because of the immense, invisible forces of momentum and gravity spinning constantly and smoothly right beneath our feet.